When 9 grams of water is produced from the reaction of its two elements, then the required number of hydrogen is how many molecules. As usual, when we have a problem like this, we have a strategy to work on solution. First, in a margin, extract the given information, the unknown information, and the relationship between them. The given information is the mass of water, which is 9 grams, and the required information or unknown is the number of hydrogen molecules. The relationship is how many hydrogen molecules are required to produce 9 grams of water. Do we have a relationship between the number and the gram? No, we have a direct relationship between the number, the Avogadro's number, and the mole. So we need first to know the ratio between the reactant H2 and the product, which is water, and then to know how many moles of water, so we can estimate how many moles of hydrogen. After that, we can easily calculate the number of molecules. When you start solution, you know that we need to set a relationship between the grams or the masses and the Avogadro's number. The common term in between them is the number of moles. If you succeeded to convert the grams into number of moles, then you will succeed to convert the number of moles into Avogadro's number. And this is easily can be done using the triangle that we learned. Usually put here the number of moles, here the molar mass, and here we have the mass in grams. The number of moles equals the mass over the molar mass. Now we know the number of moles. Then we will draw the triangle for the Avogadro's number to know how we can calculate the number of molecules from the number of moles and Avogadro's number. So first you need to write the balanced equation to know the ratio of moles between the hydrogen and water. So this is a balanced equation. Every 1 mole of hydrogen gives 1 mole of water. So we have 1-to-1 ratio. How many moles of hydrogen will give 9 grams of water? The number of moles of water equals the mass divided by the molar mass. The mass is 9 and the molar mass is 18. By calculating the atomic masses, H2, 1, atomic mass of hydrogen 1 times 2, and the oxygen 16, so we'll get 18. We will get half mole. So we have half mole of water produced. This half mole requires half mole of hydrogen because the ratio is 1-to-1. So by applying the relationship between number of moles and the Avogadro's number using the triangle. So the number of molecules equals the number of moles times Avogadro's number. We have half mole, so we have half times Avogadro's number, and the Avogadro's number equals 6.022 times 10 to the power 23. We can easily calculate it. This is the number of moles of hydrogen molecules. If we are asked to calculate the number of moles of hydrogen atoms, we have to duplicate it.